Kiddos. Welcome to Chapter 4, Lesson 8 notes. We're going to graph absolute value functions again, right? I know in Chapter 3, Lesson 6, we spent a lot of time graphing absolute value functions and transforming them, right? Because I told you because of the vertex and absolute value, it helps us to see how transformations of functions really work by adding, subtracting, adding and subtracting outside of the bars and adding and subtracting inside of the bars, right? So we need to make sure we can graph an absolute value function using our graphing calculator, which I have pulled up over here, and I'll have one over here too, as well as graphing absolute value functions, just kind of looking at their equations, right? So one of the things that I didn't do in the transforming functions lesson was I didn't go into detail about what absolute value really was. And the reason I didn't do that is because we weren't talking about the detail of why the function does what it does. We were just talking about the detail of moving it around the X and Y axis. Okay. So now let's talk about what absolute value is. Well, absolute value is a distance from zero on the number line. Absolute value is your distance from zero on the number line. So if you look at this box here, it shows you that the absolute value of 7 and the absolute value of -7 are both 7. And the reason is because it's a distance, and distance doesn't have a positive or negative attached. In the case of absolute value, the positive and the negative are just which direction away from zero it's going. Its distance, 1, 2, 3, 4, 5, 6, 7, is how far away we are. Okay. That's what absolute value is just tell me what's our distance from zero. Okay. The signs really are just giving you which direction it's going, left or right from zero on your number line. So what that really means is when you're putting absolute value bars around your X as a function, you're saying you're taking this distance. So you're taking the sign out of the equation and then doing the rest of the stuff to it. And what that creates for a linear function, which would be present, a linear function is what would be present without those absolute value bars. But what that creates is those absolute value bars create a distinct vertex. And that's what is distinctly making absolute value V shapes and A shapes. Okay, that's what's happening. Now, in that lesson, we did discuss the equation. So the general form of an absolute value equation is y equals a times the absolute value of x minus h plus k, where a is your slope on the right-hand side of the vertex. That's going to be important in a second. So a is kind of your slope of your absolute value, and hk is your vertex. Now notice that inside the bars, h is negative, but when I pull it for a vertex, it's positive. So that means that inside the bars is the opposite sign of the number I pull out. K on the outside is positive and same in the point. So this value here, this sign here, is correct in the vertex. Okay, so if we look at the parent function for absolute value that we used in Chapter 3, Lesson 6, it's y equals the absolute value of x. That's what's written right here. Okay, if we look at that and we put it into this form, we throw in the a value. We actually write it there, what's actually there, which is a 1. We throw in the vertex 0, 0. What we're doing is seeing, so we just expanded y equals the absolute value of x. We just expanded it to actually have all those numbers written in, the 1 and the 0 and the 0. Now, we wouldn't normally put those there. You know, we know that there's a 1 out here in front of the absolute value bars. We know that this is really like x minus 0 is just x because you didn't subtract anything from it. We know adding 0 out here means we just have that absolute value of x. We put them there so you can see specifically this is where those other values go. And then that's how the equation is directing the movement of the vertex and the slope of the absolute value around the vertex as you're going through the x and y axis. Okay. Back in chapter 3, lesson 6, I only discussed the equation. I didn't discuss the reason for that. Okay. I only discussed how the equation was driving that change. I didn't discuss the reasons for that, which are now here and based on what absolute value is. So that taking that absolute value of x is taking its negative sign away, taking its sign away, and just looking at its distance. And that's what's creating that vertex that moves. Okay, so now we're revisiting that chat. I've said it 4 times now, right? Chapter 3, lesson 6 was all about the transformations. This is copied and pasted from chapter 3, lesson 6. Okay, and it's just one whole page instead of how I had it before, set up with all the movements that we've done. But again, all this is color coded to match what you see here. But let me just again show you. If you start with your parent function right here that we were just discussing, its slope is 1, and that's the up 1, right 1, and it's to the right of the vertex. The vertex is 0, 0, because there's nothing added inside, nothing added outside. Now, let's move it over 1, 2, 3 to the right. So see, your vertex is now at 3, 0. Well, look at the function. Look at the equation. It's a minus 3 here, but it's 3, 0 as your vertex. And that's because this is the opposite sign here of what we think it's written in here. But 0 because we're still adding 0 on the outside of the bars. So that's why we move it over here. This is still a 1 in front of the absolute value bars. So my slope is still up 1, right 1. Now from here, let's change the slope. So let's put a 2 in front of the absolute value bars. So now look at this value. The vertex is still 3, 0 because 3 is the value here that you pull, plus 0 on the outside. But now this value says, okay, instead of up 1, right 1, it's up 2, right 1, because this is the slope. So this is determining the narrowness, the wideness or narrowness of this function. So now one more move that I'll make with this whole thing is I'm going to take now and move the whole vertex up 4. So now I've got this equation right here where for the vertex, you pull 3 and 4. 3 is the opposite sign of what's in the bars. 4 is the correct sign of what's outside of the bars. That's where my vertex is, and my slope is the number in front of the absolute value bars, up 2, right 1, up 2, right 1. That's how we can change where the absolute value function is using the equation. That's how we can predict where the absolute value function is using the equation. I can look at that equation and know where the vertex is and know how narrow or wide this function will be in its v or its a. Now, the thing about that is, and I'm just going to do this right here, right quick. Here we go. Right here, inside my graphing calculator, I'm going to press y equals, and I'm going to graph my parent function first. So y equals, to get absolute value bars, you press math, you arrow right to number, and notice ABS number 1 right here. There's my absolute value bars, and I'm going to put my x inside of it. Okay, this is my parent function. So I'm going to start by graphing this. And look, you see exactly what you see here. Okay. Now I'm going to type this one in. So let's say I just gave you this equation to graph and get you the points. This is all you have to do is plug it into y equals in your graphing calculator, press graph to see it, press second and graph to get the points. Notice the vertex was 0, 0, so look at and get the vertex in the middle of your graph, middle of your table, see 0, 0, look at those. See how the y value is the opposite sign of the negatives, but the same sign here? We've taken the negative out by using those absolute value bars for x. Now, what if I needed to graph this function right here, y equals 2 times the absolute value of x minus 3 plus 4? All I need to do is press y equals, and I can arrow down into y2. I want my 2 first because it's in front of the absolute value bars, then press math, arrow right to number, and press number 1 because that's where my absolute value bars come from. Then it's x minus 3 on the inside. Notice this right arrow has come up, so arrow out. Now we're outside, and we can put our plus 4. I don't need to memorize. I'm showing you this about the equation. I don't need to memorize that because I've got the graphing calculator that can always be there to tell me that. So now if I press graph, there's that movement. See it? See how we went from here to here? I show you gradual movements with these two middle functions, but that's how we went there. This is what we did. Those are the changes we made to the equation to get it up there. Absolute value is the A or the V shape. Okay? Absolute value is the A or the V shape. If I want to see these points for the red, I press second and graph, and look, there they are. Now, look back at the graph just real quick. See how the vertex is at 3, 4, right? See how the vertex is at 3, 4? I can see that already. But really, I only need to see around where the x value is, which is 3. So press second and graph, and you know that the x value of 3 is your vertex. Now look at your y's around it. Get that in the middle. So you want 3 kind of in the middle of your table here, and look at the y's around it. Look at that. You can see that pattern. We know what to graph based on what's going to fit on the graph, right? So these are, 0, 10, and 6, 10 are up to the points that would fit on the graph, and that's what we would graph to actually see it. So that's what we see here since we're on a 10 by 10 grid. Okay. Now, again, like I said, you do not have to memorize this equation stuff. You should be able to see it, but you've always got your graphing calculator to check that stuff. So notice I just plugged it into y equals to see what the movements were. I compared the parent function to the new function, and I can see what the movements are there. Okay, so I always have that backup plan. I always have that option. I don't need to rely on my memorization. I can look it up using the graphing calculator. I mean, obviously, it's better to know it, but you have a backup plan. And so that's what I'm going to show you here is we're going to practice describing the movement of the absolute value function, of each of the absolute value functions. On the page pictured right here is the parent function, where we know the slope is 1, and I'm just going to put 1 over 1 because we might encounter, slope is always a fraction, so we might encounter some fractional slopes. So 1 over 1, and my vertex is 0, 0. And now what I'm going to do is I'm going to look at the equation given. I'm going to tell you the change and the movement, and then I'm going to prove it to you in the graphing calculator. So again, showing you, you don't have to memorize this change in this movement. You can get it from here, but I do know it, and I'm helping you to try to know it. So let's start with A. And what I'm going to do is I'm going to leave my y1 with my parent function, and my y2 is where I'm going to make the changes for each one, okay? So I got rid of what was in y2. Let's start here. Whenever your function starts with a negative, you use the little negative button that's underneath 3, and then you can put your absolute value bars. So math, arrow right to number. Oops, I didn't mean arrow down. I want to arrow right. And then that's ABS. Put your X in there. Now, there's a negative in front, right? So this is a slope of negative 1 over 1. Did the vertex change? Am I adding anything inside? Adding or subtracting inside? No. Adding or subtracting outside? No. The vertex is still going to be 0, 0. Okay. What's the movement going to be? Well, it's now negative 1. So what are we going to do? We're going to be down like this. So this is an A shape. This is upside down. So that's the movement from the parent function, is we're going to be upside down. Okay, now let me prove that in y2. All right, so I'm going to press graph. There you go. There's the blue original, and there's the red change. Upside down. Same vertex, opposite slope. Okay. I'm going to go back to y equals. I'll get rid of that guy, and we'll start anew. Let's do b. So we've got g of x equals 3 absolute value x. Okay. So the 3 on the outside is the only thing that changed. It's a positive 3, so that means my slope is 3 over 1. Am I adding anything in the bars? No. Am I adding anything out of the bars? No. Adding or subtracting, I guess I should say. So my vertex is still going to be 0, 0. But look at that increased slope. That value for slope is larger, so the whole thing, the whole V is going to narrow. So this is going to narrow from a slope of 1. And let's prove that. Okay, again, the blue is always going to be our, the blue in the graphing calculator, it's always going to be our original. And now our red is going to be our changed one. So we put a 3 in front of the absolute value bars and then press math, arrow right to number, enter, and then put our X in there. And this is the only thing we're graphing. So we can press graph to see it, and look at that. It takes that original blue function and it narrows it because it's sloped up more, right? And now it's up 3 and right 1, up 3 and right 1. Okay, so it worked. So notice I could find all this information just from plugging into the graphing calculator. I don't have to memorize this, but I'm showing you how quick it is when you do have it memorized. All right. C, now we've got a 1/3 in front of the absolute value bars. So go to y equals, get rid of this guy, and now it's a 1/3, it's a fraction, right? So fractional slope is front parenthesis 1 divided by 3, right? Because fractions are just mini division problems. End parenthesis. Now we can put our absolute value bar, so math, arrow right to number, and then put our X in there. That's all we have. There's no 0. There's 0 inside. There's 0 outside. This is still a 0, 0 vertex. But now your slope in front is 1/3. What does that mean? What's that going to mean from our blue function? It's going to be wider. Look how wide it is. Look how much wider it is. It took your regular V and it widened it out. Okay, so this has gotten wider. So that's what the number in front of the absolute value bars is, because it's your slope. It's going to make you narrower or wider. So now D here. Oh, there's finally a change inside the bars. Okay, so what I'm going to do is I'm going to, of course, leave Y1, but I'm going to delete what's in front of the bars so I don't have to keep looking for them. Now I'm going to arrow inside, okay? And notice when I go to arrow with the X, my arrow appears here. So I can just press +3 and I'm still inside the bars. Now I can arrow out. Now +3 means what comes out of this for the vertex is a -3 for the X value of the vertex. Is there anything added or subtracted out here? No. So it's still a 0 for the Y part of the vertex. But this has told me the vertex moved left because it's -3. So it moved left. Has the slope changed from the original? No, the slope is 1/1. So where did this move? And let's just prove it. It went left 3. Look, our vertex moved left 1, 2, 3. And again, I can tell it's left because of adding inside the bars. It's the opposite of what you think it should be, right? It's the opposite sign of what you think. Okay, E is a minus inside the bars. So that'll be an easy switch in Y equals. So go to Y equals, arrow down. Let's get in those bars and let's change this plus sign to a minus sign. So I just wrote right over it in my graphing calculator. So that's what we got here. Press graph to see it. Right 3. So see that? Because this, it's not -3 here. Well, that means a 3 comes out of here. Nothing added or subtracted, so 0 for the Y. The number in front is still 1/1. So what's your movement? Right 3. Okay. All right. So here we've got a -3 outside the bars, right? So go to your absolute value, go to your y2. And then in here, we need to delete. Our arrow shows up. Do we want to come out? Yep, we want a right arrow out. And now -3, okay? And then here, right, this, a -3 out of the bars is going to be a down 3 movement, because is there anything added or subtracted inside? No, so the vertex is 0, so that's on the y-axis. But now we've got this -3 that comes right here, so that's down 3 on the y-axis. So that's how we know, okay? That's how we know that it's a movement of down 3, and let's just prove it again, because I keep proving it for you. There we are, right? We took our vertex, we moved it down 3. All right, last couple. This is the last real movement, like single movement, and then we'll kind of double up our movements a little bit. But here, there's a +3 out here. So y equals, let's go change it to a +3. And because there's a +3 out here, we know that the vertex, nothing on the inside, +3 on the outside. So the vertex is 0, 3. So that takes it and moves it up 3, right? So let's just prove it by pressing graph. And again, if you don't know these things, plug them into this graphing calculator and see it. Plug that equation into the graphing calculator and see this movement up. We went up 3, so we're at 0, 3. So now when I combine several of these things in n of x, so I'm going to leave my parent function right here, and this red is going to be all several of these things. I'm going to clear it out and just start over. -2 on the outside, then math, arrow right to number, and ABS is our absolute value bars, and then it's x +3 inside, and then arrow right out for -4 outside, okay? So our slope is the number in front of the absolute value bars. That's -2/1. So that means this is going to narrow and be upside down because of the negative. So it's going to narrow and be upside down. The vertex is -3, -4. So what's the movement? Left 3, down 4, narrowed, and upside down. So left 3, down 4, narrowed, upside down. Each of those changes in the equation makes that movement. And let's just look. There's the original, left 3. So left 3, down 4, narrowed, upside down. There it is. That's how I can tell. So that's a great review from chapter 3, right? Those movements. You need to be able to tell by looking at the equation. You can prove it in your graphing calculator if you don't have that memorized, but you really should. Okay, you really should. So let me just zoom out real quick here so you can make sure you have all that. Okay, and pause on it if you need to make sure that you have all those things and why, and look at the equations and see why. Okay. Leave that parent function. I'm getting rid of all the movement ones. All right. Now we're going to graph. Okay. So we're going to consider the parent function, right? Describe the slope, the vertex, the movements, and then we're going to graph it. So I'll start with P of X right here. Notice I'm naming all these guys different letters, so we have lots of different functions we're talking about. So looking at the equation, I can see, okay, the slope in front, that's a 1/1 because there's no other number listed. There's no negative there. The vertex going from changing here, it's going to go 3, 2, which means right 3, up 2. So what's the vertex again of y equals x? Just remind yourself, look right here. The vertex of y equals x is 0, 0. So From 0, 0, go right 3, up 2, and now a slope of 1 over 1 to the right. Now we know that this is the vertex, so that means this side just matches up. And since it's absolute value, those are two linears that meet at that vertex. I use my straight edge to connect. Okay, I use my straight edge to connect. Just like this. Arrows at the end because I did not have a domain limit, and label P of X equals the absolute value of X minus 3 plus 2. There you go. Prove it. Over here. Math, arrow right to number, ABS. You've got X minus 3 inside, arrow to the right, plus 2 outside. Press graph to see both. Now press second and graph to see the table, and look at the table for the red. Look, 3, 2, 2, 3, 4, 3, right? So those are on each side. Let's double check those. 2, 3, 4, 3. Look, those are points I graphed already. Okay? Those were points that I graphed. If you use the graphing calculator to get these points, then you do write your table next to your problem. So I was asked to graph, and I'm going to the graphing calculator to get my points, because if I'm someone out there who doesn't know what this equation is telling them about the vertex and slope, that's fine. You're getting it from here. Write it down. Show me that you're getting it from there. Well, the vertex is 3, 2, so let's get points on each side of it. So like we had said, 2, 3, and we had said 4, 3, and then we've got points on each side, so 1, 4, and 5, 4. So 1, 4 on that side, and 5, 4 on this side. And then over here, okay, I've got 6, 5, and I've got 0, 5, right? And that's plenty to write down. That's plenty of a table to write down, right? 0, 5, 6, 5. That's what you're seeing. Okay. When it comes to absolute value, put that vertex in the middle like that. And then, of course, J. So now, let me go back into y equals. This time I'll do it like I don't know what I'm doing. Okay. So let's say I don't know what I'm doing, but I see that I have to graph a function. I'm told I have to graph a function. Q of x equals negative absolute value of x plus 1 minus 5. Sure. So the negative starts the function. So I put a negative out front. I need absolute value bars, math, arrow right to number, ABS. I do x plus 1 on the inside, arrow right, minus 5 on the outside. Cool. I don't know what this is going to look like. In fact, I don't want to compare it to anything. So I'm just going to press enter, get rid of my parent function. I only want to see this red one. So if I press graph, I'm only going to see the red one. And there it is. Okay. No problem. No sweat. Let's see what the points are. Second and graph. Wait a minute. Let me go back to the graph. The vertex looks like it's negative 1-ish. So let's get things around the negative 1 on my graph. So let's get things around the negative 1. Oops, on my table. There we go. Let's get things around the negative 1 on my table. So there it is. Look at that. Negative 1, negative 5 is the vertex. So I'm just going to graph a couple points around it. Remember, in this case, it's a 6 by 6 grid I had. So negative 1, negative 5. Oh, I'm really not going to be able to graph many points, am I? So negative 2, negative 6, and 0, negative 6. That's all I can fix. This is a 6 by 6. So negative 1, negative 5, 2, negative 6, and 0, negative 6. There we go. I mean, I still need to use my straight edge, but there it is. I put it on a graph, so it has to be labeled. Absolute value, we always use a straight edge to connect at the vertex. And anything we put on a graph, we have to label with its equation. So there it is. Okay. What's the slope on this guy? Well, it's down 1, right 1. So negative 1 over 1. Look at that. Negative 1 in front of the absolute value bars. What's the vertex on this guy? Well, it's negative 1, negative 5. And what's the movement from this? Well, we went left 1, down 5, and up upside down. There you go. That's what we're looking at, okay? Now, if I give you the equation and I give you the function, you should be able to plug into this and write the equation, okay? So what I'm going to do, and this is how I'm going to write the equation, is I'm going to grab the vertex and I'm going to count the slope, and then I'm going to plug those in to make the equation. Okay, so for number one, the vertex looks like 0, 0. Slope is down 1, right 1, down 1, right 1. See that? So the slope, or A value, is negative 1 over 1. The vertex, which gives you my H and my K, is 0, 0. So I'm going to plug those into, it's highlighted right here. I'm going to plug those into the general form, and then I'll simplify what I can. So y equals A is negative 1 over 1. Absolute value of x minus 0 and absolute value plus 0 on the outside. Can I simplify this? Sure can. 1 over 1, right? Negative 1 over 1 is negative outside. Absolute value bars, x minus 0 is still x, plus 1 on the outside doesn't need to be written. There's my answer. That's my equation. Let's do it again. Let's do it over here at number 2. What's the vertex? 1, 2, 3, negative 3, negative 2. So the vertex is negative 3, negative 2. So that's my H and my K. My slope is up 1, right 1. So my slope, or my A value in this case, is positive 1 over 1. Okay, now let's plug that into the general form, right? So y equals 1 over 1, absolute value of x minus a minus 3, I'm doing that on purpose, and absolute value minus 2 on the outside. Again, we can simplify a little bit. We don't need to write 1 over 1. We don't need to write the 1 at all in front of the absolute value bars. If it's not written, it's still, we know it's there. Negative minus, right? Minus a minus is really plus a positive. So this can be written as x plus 3, and that explains the sign change thing. Minus 2 on the outside. There's your equation. Hey, if you don't believe me, let's plug that into the graphing calculator and look at it, right? Plug it in right here and look at it. Go to y equals. I'm just going to change y2 because that's what's there, right? So let's look. Let's see if that's correct. So math, arrow right to number, get absolute value in there, and then x plus 3, and then arrow outside, arrow right outside, minus 2. And now you've got graph. And look at what this graph is, and look at what that graph is. And yep, that vertex, I know this is a smaller version. It's more zoomed into one side, but that's it. That's the function. So I just checked my answer to make sure I was correct using my graphing calculator. So let's go again right here. And this one's just fantastic. I mean, count the slope, right? Up 1, right 1. This is a slope of 1 and a vertex of 0, 0. So this is the basic absolute value function. Okay. That's the basic absolute value function. I gave you that one on purpose to kind of show you that's a possibility. You never know. That's the parent function right there. Okay, and then there's number 4, of course. The vertex is 0, 0, so nice and easy to see. But here, slope is up 2, oh, nope, 3, right 1 to get to the next point. Up 3, right 1 to get to the next point. So your slope is 3 over 1. So plugging in, and now you can probably go to it right away, right? It just means a 3 in front of the absolute value bars, no adding or subtracting on the outside because your vertex was 0, 0. So if I give you that general form, you should be able to plug into it given the slope of your absolute value and your vertex of your absolute value. Okay, but I'll give you that. Up here, if I give you a function, you should be able to plug it into the graphing calculator and graph it, or look at it to find the vertex and the slope and graph it that way. So you saw me do that over here at P of X. But over at Q of X, you saw me just plug it into the graphing calculator and graph from my table. Either way works. The graphing calculator is an amazing tool that you can use to check what you're doing with these functions. Okay, you just got to go to y equals and plug those guys in. You can do this. That's something you are more than capable of doing. And that helps you check your work as you go. All righty, guys. I've taken up enough of your time for the last lesson of chapter 4. Good luck revisiting absolute value. One of my faves, great function, that absolute value, A's and V's always, right? And if you have any questions, we are at the end of chapter 4, so please let me know before we have that exam. Exam review, exam. I'll be seeing you guys. Bye.